Today we are going to do the same thing you run like last time, titration, but this is something different, that you are using a powder of, first step, that you have to weigh approximately 700 to 900 milligrams of ferrous ammonium sulfate. Which is in that under the hood in the white bottle as already showed you. And then this ferrous ammonium sulfate you have to dissolve in the acid. So the second step is add about 15 ml of 3 molar sulfuric acid. Okay, just shake well the powder. If the powder is not dissolved, then you can add like to about like 10 ml of water. If the powder don't dissolve with the acid, then only you have to add water. Otherwise, you don't need to. Okay. Why you have to dissolve that compound in the acid? Because if you not dissolve in the acid, then finally you will get a gelatinous structure because it's converted into manganese oxide, which is not good. So you have to add acid. This one, you need acidic medium for the experiment, right? So this one has to dissolve over here, otherwise it will form manganese oxide, which is in gelatin form. You don't need that. You want liquid form, and for that you have to dissolve this compound into the acid. What? It doesn't work. If you don't add acid, the experiment not gonna work. Yes, if it's not dissolved with the H2SO4, if you shake it well, it should be disappeared. But if it's not, then you can add 10 ml of water. Okay? And then after addition of 10 ml of water, you can fill up borates with the permanganate KMNO4, which is already over there, and it's quite like 20 millimolar about, and you are checking this one. You are checking the molarity with this experiment. Okay, this is about 20 millimolar. So you have to check it if it's correct or not. Fill the burette with the KMNO4 and then start titration. Add drop by drop. Okay, only drop by drop, not like the last time you did. You cannot do the same way. Add drop by drop, because when you add into the flask, the color of permanganate will be disappear. And when the reaction is complete, when the ferrous runs out, at that time the solution is gonna be light pink color. So at the end, you will find in the flask is the colorless solution is converted into the color solution. Okay. When you dissolve the ferrous into the acid, then the solution will be colorless, and when you add permanganate drop by drop, at the end of the reaction you will get color solution, the light pink color. Okay, and then you can compute the. Okay, the fifth step is repeat the experiment 3 times. So you will get 3 different volumes. Now you have to compute the molarity of permanganate, right? So molarity of permanganate is equal to mole of permanganate divided by volume of permanganate. From where you get this volume? From that. From the burette, whatever the volume you get, you have to use over here. Now, how you will find the mole of KMNO4? Mole of KMNO4 is equal to mole of ferrous ammonium sulfate multiplied by the factor. Which factor? Mole of KMNO4 divided by mole of FAS. Okay. Now how you will find this one? Yeah, I'm gonna explain that. I'm explaining. Okay. From where you get this mole of FAS? Mole of ferric ammonium sulfate is equal to the amount of FAS you are taking in the beginning. Like this one, 700 to 900, whatever you are taking in the beginning, you have to note that. And that amount you have to write down over here in the beginning. Okay? And it's divided by molar mass. And the molar mass is 392 points, let me see, 392.14. 392.14 gram. Okay, over here you are taking into the milligrams, so you have to convert this one into grams. Okay, and whatever volume you are getting is into the ml, so multiply by -3. Volume over here you have to multiply this with the 10⁻3, so it will be converted into the liters because you want the answer in the liter. Okay, and this factor is 1:5. How this is 1:5? Jorge is already explained you that you need 1 permanganate to oxidize 5 of ferrous. So it's 1:5. Okay, you can see in the first blackboard over here, 1 permanganate is required to get 5 Fe plus 2. So that's why the ratio is 1:5. Anybody has question? Everything is clear, right? Okay.
So after we divide the mole of KMNO4 by the mole of the FAS, we then multiply by 1/5 again, or is that?
This one is mole of FAS, so you have to calculate this one first.
Yeah.
When you get that answer, then multiply by 1/5. Okay, so you will get this one. So this one you will use over here, and this one you will use over here. So ultimately you will get the molarity of permanganate. Then take average of molarity because you are repeating it 3 times. So take average from 3 experiments and 3 calculation and average the molarity. Yes.
Why do you need the volume of FAS?
What?
Why do you need the volume of FAS?
When I tell you, where is written over there? Show me.
Volume of KMNO4.
Yeah, you need a volume of KMNO4 because you are taking KMNO4 into the burette. And you need the molarity of KMNO4. You are. That's the standard. That's the standard to get molarity of KMNO4. You need that standard.
There is no volume of FAS, you are using powder.
I know you are using a powder. I mentioned over here is 700 to 900 milligrams.
You are not going to use a volumetric flask. You are not going to use a volume. You are using 1 burette of KMNO4.
Okay. Anybody else have a question?